Hello, everyone. It's the Alchemist, and today we're looking at the code problem of the day for Thursday, April 18th. The problem today is called Island Perimeter. We can read through our description real quick. It says you're given a row by column grid representing a map where grid ij equals 1 represents land and grid ij equals 0 represents water. And at the bottom, they gave us this helpful little illustration showing what that might look like. It says then grid cells are connected horizontally/vertically, not diagonally. So we can see that here. All the grid cells are connected either above, below, left, or right of another grid cell. There's no diagonal connections like there would be right here. Then it says the grid is completely surrounded by water, and there is exactly one island. That is one or more connected land cells. So what it's saying with that is that the grid that we're given, the data, right, might only be composed of this 4 by 4 matrix, but everything outside of this is technically considered water. And that's going to be important in a second when we find out what our goal is in this problem. It says then the island doesn't have lakes, meaning the water inside isn't connected to the water around the island. And then it says one cell is a square with side length 1. The grid is rectangular, width and height don't exceed 100. And then finally, our problem statement, determine the perimeter of the island. So, since this is our goal, we'll write that up here to remind us, determine the perimeter of the island. So, how can we do that? There are multiple different solutions, including some very clever mathematical solutions. However, I always prefer to go for the solution that makes the most sense logically to me. And I hope that this solution will make the most sense logically to you guys as well. And that is the depth first search solution. And so, in order to do that, we're going to take a look at this example grid, right? Since we know that all the land pieces are connected, we can say that whenever we encounter a piece of land, that there either must be a land above it, below it, left and right of it, or there's a water above it, to the left of it, to the right of it, or beneath it. If there's water to the right of it, or left of it, or up or down, whichever direction you go, you know that you must be at an edge piece. And you can add 1 to your total perimeter, right? Because if we're here, right, at this land piece, and we go to the right and we're in the water, we know that we must have gone off an edge. And an edge is part of our perimeter, so we know we can add 1 to our total perimeter. If we go down, let's say, and we encounter another land, we know that we're not at an edge. And so instead of adding to our perimeter, we keep going until we find all the possible edges. Remember also that water does not exist only inside the grid. Water exists at or outside the boundaries of the grid as well. So we'll not only need to check that we are at a water square within the grid, we'll need to check if we're outside of the grid as well, because then we'd be in the water, but we technically would not be at a point that exists within this 2D grid. One more thing to note is that we want to make sure we don't repeat squares. So for example, if we start at this square and we go up, left, right, and down, right, we're going to go down to this square and we're going to say, okay, we're at another land. So now we need to go down, left, right, and up. Our problem there is that if we go up, we're going to end up in an infinite loop because now we're back to where we started. And so we need to maintain a list or a set of all of the previously visited cells. So let's start coding. Hopefully this solution will make a little more sense to you, right? So first, we want to have our set that keeps track of all the visited cells. So we can put that into a attribute of the class, right? So we'll write an init method, and then we'll just say self.scene equals set. And we'll create an empty set to keep track of our scene cells. Then right, we're going to do our first step, which is we have to actually find a piece of land to do our recursion and depth first search on, right? We have to find the first piece of an island so that we can start finding the edges of that island and the other parts of that island. So we're going to loop through this grid, and we're going to say for y in len grid, right? For x in len grid 0. Essentially, what that's saying is, say you had a 2D matrix like this, right? It's essentially an array of arrays, or in Python, a list of lists. So you're going to loop through your first list, right, which is going to contain all of these nested lists here. When you get to one of these nested lists, you have to loop through each cell within the nested list. So that's what this for x in len grid 0 is. This is, since all of the grid rows are going to be the same length, we can just use grid 0. But if you had different lengths for each of these different rows, then you could do grid y and you would get the length of that specific row. But we're not too concerned about that since we know they're all going to be the same length because it's a rectangle. We can say for x in len grid 0, if grid y x is equal to 1, meaning it's a land, then we're going to call our depth first search function, right? We're going to call our depth first search function on that y and x, and we're going to pass in the grid as well. We're now going to write our depth first search function, dfs, right? And we're going to say y, x, grid. That's what our method signature is going to look like. And then we're going to say if x comma y in scene return 0. So if we've already been to this cell, return a 0. Don't add anything to the perimeter. Now we need to check if we're in a water square. So we'll first check if we're out of bounds. We need to check this first because we can't check if we're at a water square first, because if we are out of bounds and we try to access an out of bounds element of the grid, we're going to get an error. So we need to first say, right, if x is less than 0 or y is less than 0, right? So if we're out of bounds on either the left or the upside, then, or, right, x is equal to len grid 0, or y is equal to len grid. And so again, that's just saying, have we exceeded the boundaries of our grid, right? Because you'll remember, lists/arrays are 0 indexed. And so if you're at the length of the list, you're at an index outside of that list. So if any of those are true, or if we haven't evaluated true for any of those, if grid y x is a water, right, equals 0, then return 1, right? Because we are at, or we have just gone off of an edge, and so we can say that we've seen an edge and we can add 1 to our total perimeter. Now, what we want to do, right, if we are still executing code at this point, we know we must be on a land, because if we were on a water, we would have returned and exited this function. So now that we know we're on a land, and we know we're on a land that we haven't seen, because if we were seen, we would have returned up here. We have to add this cell to the list of seen cells. So I'm going to do self.scene.add x comma y. I might just make sure that we're only going to visit this cell one singular time. over the life of our code. Then we can say, let's do a recursion. We can say return, because we want to sum the results from all these different recursive calls, self.dfs y plus 1 x grid plus, right, self.dfs y minus 1 x grid. And in this way, we're sort of going to the left, right, up, and down, all of the 4 possible directions that we can move, and checking for either another land or a water square, in which case we can add to our perimeter. And so, with that, and we just got to make sure we add a return here, clean this up, we can give our code a run to see if we have any errors. We do. Let's see. Can debug this real quick. Type error int object is not iterable. For y and len, okay, so that makes sense. What I meant to do here was use a range, right? Because we are not looping through the length of the grid as an integer, so it doesn't really make sense to can't loop through an integer. Instead, we have to create an iterable range. So doing that now, we can run our code. And another little silly mistake, you have to remember this is an attribute of the class, or property of the class, and so we have to add the self dot prefix. And you'll see, oh boy, even more even more errors. Solution.dfs missing one required positional argument grid. And it looks like I lazily left off the grid variable here. So fingers crossed, and there we go. Right, we passed all of our test cases, and with a fairly decent runtime of 34 milliseconds. Now let's submit and see if we can pass off all of our test cases. And there you have it. Not a great runtime and not a great memory consumption. If we were going to analyze the big O, right, of our time complexity and our space complexity, though, we would see that our big O is first time complexity is O of n, right? Because each square should theoretically only be visited once, maybe twice, right? There are a few times in which it might be more than once. However, for the most part, cells should only be being visited once or maybe 2 or 3 times more than that. But that would then be 3 of n, and in time complexity, we're talking about asymptotic time complexity. And so we don't use integers here, we just say O of n because it's not an order of complexity greater than O of n. Our space complexity would be at a max something akin to O of n as well, right? Which is because we have a potential chance for a recursive call at every single square, right? And so if we have a recursive call at every single square, right, that's new space. It's got to get taken up on the stack for your function to be called. And so that's going to take up O(n) of space every time. Additionally, we also have our scene set, and that could also contain one of every element of the grid, in which case that would also be O of n space complexity. They're both O of n, but again, remember, unless they're an order of complexity higher, there's no 2n, right? We're just worried about the asymptotic complexity. And since this follows a linear asymptotic complexity, we say that our space complexity is O of n. That went a little over your head. Don't worry. A little complicated to get the hang of, but something that hopefully you will pick up as time goes on and you do more and more of these problems.